Hello everyone, my name is Pritam Paul and welcome to another video. And in this video we are going to start a new playlist which is another data structure which is tree. In the introduction video I have told you guys I will be explaining like linked list, stack, queue, tree, graph and so on. So this is the playlist for tree. Okay, so before starting tree we need to understand what exactly tree is. Tree is something like this is a hierarchical manner. Okay, you might have seen in various places in your real life scenario. This is a hierarchical manner by which like tree has been represented in data structures. Okay, now this is a non-linear data structure. Why? We will talk about it later when we will implement the tree using like representation of tree. We will discuss, we will get to know. You need to understand that the data structures which you have been gone through like linked list, stack, queue, array, string, all these are linear data structures and they are having some disadvantages which is we will see in searching. Like for example, there is a an array or there is a linked list. Okay, or there could be a stack. Okay, or there could be queues. Okay, so what are the disadvantages here? When you start searching for an element, okay, you need to go through like from front to end, you need to go through, okay, which takes O of n time complexity. Now just think about it, like if the number of elements here is like number of elements are this, when you will be working with real life data like Facebook. Okay, so Facebook is having billions of users. So if you use an array to store the data and if you search for it and the data is in like for example in the last part, okay, then what will happen? Obviously it is going to take a much longer time. If for each time it is taking for example 1 second, okay, for example, then for this what 1 2 3 4 5 6 7 1 crore. Okay, so 1 crore second it is going to take. But if you use data structure, there the searching time complexity is log of n. Okay, n is the number of element, so obviously log of 10 to the power 7 which takes only 7 seconds. Okay, which takes only 7 seconds here, whereas here is 1 crore second. Where is 7 second, where is 1 crore? Okay, the larger number of data would be there, the less time, like the difference would be larger. We can make a graph of it like this, like if the linear is this, log n is this. Okay, that's why I'm just log n is like this. Okay, so that's how the thing is, like when like if it is 10, number of 10, then obviously it is going to take 10 seconds, and here log of 10 which is going to take 1 second, difference is 9, but here 1 crore and 7 second. So the difference is much bigger when the number of data is obviously very large. Okay, now you need to understand what is the number advantage of nonlinear data structures. Because of searching and doing other operations, we need nonlinear data structures. Like for example, you are designing a social network, obviously you will be needed a graph. So graph would be like this. Okay, so you need a graph. So that's the thing, you can't use array here. In the similar way, there are a lot of advantages of tree also over linked list, stack, queue, array or string. Okay, and that is the thing which you are going to explain. Okay, so these advantages I have talked about, and also advantages. Okay, now let's start the tree data structure. So this is a demo of a tree data structure, and now how it is going to be executed. Like this is a node. Okay, these are called nodes. These round things are called nodes, and all these lines you can see here, these are called edges. Okay, these are called edges. Yeah, so there are few terms which we are going to discuss. First of all, node. I have told you, node is a like this, it will have the data. Okay, so node could be explained like each element of the tree is called a node. Okay, in the figure like here, these are the nodes. You can see what are edge. Okay, after node it is called edge. Okay, so what are edges? Edges are like two connecting line between two nodes are called edges. Okay, now parent node, for example, this is a case. Okay, so the upper one is called a parent node and the lower ones are called child nodes. For example, in this case, this is a parent node and these are child node. This is a parent node, these are child node. This is a parent node, this is child node, and this is a parent node, and all of them are the child nodes. Okay, now there are various types of child nodes like left node, right node. Oh, sorry, once again. Okay, left child, right child, I haven't written, I'm really sorry. um in child node, like left child, right child, there are two right child nodes. And what is root node? Now root node is only one. In a tree there could be only one root node, which is the topmost node of the tree, which is the root node from where the tree is being created. Okay, now if I talk about leaf node, then what are leaf nodes? Leaf nodes are this, the last level, like lowest level nodes are called leaf nodes. Okay, are called leaf nodes. And if I talk about levels, now levels are like this. For example, this is one level, this is another level, this is another level, and this is another level. Okay, these are called levels. Now this is level 1, this is level 2, this is level 3, and this is level 4. Okay, so now the thing is like height. What is the height of a tree? So height is the, like height equal to, what we can write is height equal to number of level plus 1. Like here the number of level is like this starts from 0, 1, 2, and 3. So the number of level is like, number of levels are like 3, maximum level is 3. So obviously height equal to 3 plus 1, which is equal to 4. Okay, this is the basic definition, but in different books there are different definitions. Okay, for example, if in any book it starts from 1 and then 2 and then 3 and then 4, in that case height equal to level. But if you start from 0, then obviously height would be equal to level plus 1. Okay, now what are siblings? Obviously siblings are like this. For example, B, C, R, E. Okay, B, C, R, E, all these are siblings of this parent node, right? So obviously these are the siblings. Now these siblings, these are 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 siblings. Sibling node means like created or extended from the same parent node. Okay, path. Now what is a path? We talked about siblings, now we will talk about path. Now what exactly the path is? Okay, now path is what? Like for example, this is the node. Okay, so now path is a way to reach to your, to reach out your root node. So this is the path. Okay, MBHO, this is a path for O. For you, this is a path. For this is a path. For this is a path. In this way we can say, like to define the path, like for example, for this the path would be like MBHP. This is the way we write the paths. Okay, Now we will talk about sibling path. Now ancestors and descendant. Okay. Now for example, from this node has been created. Then this is going to called descendant, and this is going to called ancestor. Okay, ancestor and descendant. Then that means the parent node is called the ancestor and the child node is called the descendant. For this is the ancestor and this is the descendant. Okay, like for this is the descendant and this is the ancestor, but for in this case this is ancestor and this is descendant, so it depends. Okay, the previous version, like the source would be as ancestor and the lower one would be the descendant. Now sibling path and now what is subtree? It's a very interesting thing. Subtree is what? This is a subtree, this is a subtree, this is a subtree. A subset of a tree is called a subtree. Okay, this is a subtree, this is a subtree, this is a subtree. Okay, this is also a subtree, this might be a subtree. So in this way we can discuss. Okay, we can say the subtrees. Now what is a degree? Degree means the number of edges connected with a node is called a degree. For example, if I say this node will have the degree which is 4. Why? Because of this one, this one, this one and this one. Okay, now if I talk about this node, okay, then what will happen? Obviously, let me know in the comment section. Obviously it would be 1 2 3. For this node it would be 1 2 3. For this 1 2 3. For this 1 and 2. For this 1 2 3. So in this way we can see the degrees. Now forest means forest means what? A forest is a set of disjoint trees where n greater than 0. If the root of the tree is removed, we can get a lot of forest containing its subtrees. For example, if we remove it, okay, now you can see a lot of subtrees. Which one? Like for example, this one also, this one also, and this one also. All of them together we can call forest. Okay, that means without this one, the root node, all those things would be called as, like together will be called as forest. I hope this is the basic things which you are getting. Okay, in the tree is a very big chapter, very big topic. So there are different types of trees, like binary trees. Inside of binary trees we can have strictly binary trees, extended binary tree, full binary tree, complete binary tree. Then binary tree properties, representation of binary trees, like the way using array it is implemented, using linked list is implemented, traversal of a binary tree, pre-order, in-order, post-order, level order traversal. Then creation of binary trees from in-order and post-order traversal. We will talk about them for sure, don't worry. And also creation of binary tree from in-order and post-order. Why can't we make the tree from one kind of traversal only? We will talk about that also. Then expression tree is a very small topic. Then binary search tree, traversal, searching, finding nodes, the minimum and maximum values, like insertion, deletion. Then threaded binary tree is a very interesting topic. Insertion and deletion, we will talk about. AVL tree is very important for your career if you want to be a good software engineer. Then like balanced binary search tree, we used to call it AVL tree. It's another history of itself it is having. So tree rotation kya hota hai, like left rotation, right rotation, there are so many things. Then insertion and deletion, and then heap, then max heap, mean heap, insertion, deletion, building heap. There are a lot of things, heapify method and all. Every single thing we are going to discuss. There are many more things like lead break tree, B tree, B plus tree. These are the advanced topics, that's why I'm not including them in this playlist. I will be talking about all these things which I have told you right now. So see you in the next video. We will start by binary tree. Okay, thank you so much guys, and if you like these videos, please subscribe the channel and share these videos with your friends, and let me know in the comment section if I am having like any if I am lagging behind for few things, or what could I improve. Any kind of suggestions, please let me know in the comment section. Thank you so much. See you in the next video.